Hello everybody. So what we're going to be looking at today is graphs of sine and cosine functions. And so this is called part one because it's going to take more than one lecture to get through this material. So yeah, so let's go ahead and get started. I need to draw a unit circle here. 1, 2, 3, 4, 5, 6, 7, 8. Let's go up here. Make a circle. It made a circle. Let's see if I can do this. So I got that up there. This needs to be bigger. A little bit bigger. Okay, that's good enough. So there's a unit circle, and we need to draw in some angles here. So I'm going to draw these in radians and not in degrees. So we have 0 radians right here. Of course, we know where 45 is. We know what a 45 degree angle looks like anyway. About like that, right? Does that look 45 degrees? I'm going to call that 45 degrees. But in radians, that's pi over 4. Straight up, didn't really leave myself enough room here. I don't know if I can do this. I'm going to try. That was not what I wanted. I'm going to try to move this title. Wish me luck. Oh, it worked. It worked. Okay. So up here we have pi over 2. We've got a 3/4 pi over here. I'm not going to draw it perfectly. Oh, well, I could have done better than that, though. About like that. Good enough. Call that 3 pi over 4. And out here is pi. And I'm not going to draw that many angles in the lower half just because I'm lazy. So down here is 3 pi over 2. And then if you go all the way around the circle, you'll get around to 2 pi. Okay, so there's a unit circle. I recommend that you use a real unit circle and not mine. So where's a real unit circle? Right, if you go to the course website, I have to log in. We need to find our class. Where is it? There it is. Oh, what are we looking for? Handouts and notes. Get the unit circle. There it is. Okay, and so I'm going to label some of these points on our unit circle, and then we are going to get going on our graph. Okay, so let's see here. I need to close this because iPad sucks. Open this up. All right, here we go. So I need the x and the y coordinates at each of these points. So I'm going to do that in a different color to make it easier to see. So this point here is going to be 1, 0. This point here is square root 2 over 2, square root 2 over 2. Up here we have 0, 1. Over here, that would be negative square root 2 over 2, comma, positive square root 2 over 2. Over here, negative 1, 0. Down here, 0, comma, negative 1. And then if you come back around, you get to 1, 0 again. So I've got those points labeled here on my graph. Now, what that lets you do is it lets you make a graph of the function y equals sine x or y equals cosine x. So let's make those graphs, okay? So let's say we want to graph y equals sine x. Okay? Just in 0 to 2 pi, just that region, okay? If you wanted to graph a function, you should remember how to do this, just graphing a function. To graph a function, we just need a table of x and y values. So let's put them on here. So if for my x values I pick angles, I'm going to go 0. I guess I'll pick pi over 4. Pi over 2. I'm going to skip 3/4 pi. I'm just going to go to pi, and then 3 pi over 2, and then 2 pi. And that'll be all the way around the circle. So if you want to graph the sine, remember that on the unit circle, the sine is the y value. Now this y, like when we talk about x and y here, I'm not talking about the x and y on the unit circle, but I kind of am for sine, because when you do the sine of x, right, or sorry, when you do the sine on the unit circle, you're looking at the y value, just because you know that cosine theta is x and sine theta is y. So that's why. So if we're doing this for sine x, we want to list all the sine values. So sine of 0 is going to be the y value right there. So that's 0. And sine of pi over 4 is going to be the y value here. So that's square root 2 over 2. Sine of pi over 2 is going to be 1. I jumped past 3/4 pi and I went here. So the sine is going to be 0. Sine of pi is 0. Then we go down to 3 pi over 2. Get the sine value there. It's -1. And then if we go all the way around, we're back to the same point we started with. And so the sine of 2 pi is going to be 0 again. Okay, now let's see what that looks like if we put this on a regular graph of a function like an xy coordinate plane. So we need an xy coordinate plane. So let's graph it. Okay, so I mostly just want this plotted between 0 and 2 pi right now. So let's do this. So I've got 1/4 pi there. So let's call this 1/4 pi, which means this would be half pi then. So what I've set up here is axes where it looks like 4 boxes on my graph paper is pi over 2. So if I go 4 more, 1, 2, 3, 4 to here, this should be pi. 1, 2, 3, 4. This should be 3 pi over 2. And 1, 2, 3, 4. This should be 2 pi. Okay. Now, then I need some scale for the y. So let's just say 2 boxes is 1/2. So that's 1/2. 2 more boxes, that's 1. Then down this way, 1/2 negative, and 2 more -1. Okay, now we need to graph this. But if we are going to graph it, one thing we're going to need to know is how big square root 2 over 2 is. So if you grab a calculator, which I should have one right here, thought I did. Now I do. So if you grab a calculator and we want to evaluate what is square root 2 over 2 as a decimal, it's about 0.707. Okay, so let's make our graph now. So we plot our x and our y coordinates on this graph. So x equals 0, y equals 0. So that's 0, 0 on the graph. Then I've got pi over 4, comma 0.7. So pi over 4, 0.7 is going to be about right there, right? Just above that is 7.5. Sorry, is 0.75. Then we have pi over 2, comma 1. So that would be right here. Then we've got pi, comma 0, which is right here. 3 pi over 2, comma -1, which is down here. And then 2 pi, comma 0, which is right here. Okay, now I didn't plot them, but if you go to make this graph here, you're starting at 0, 0, and then you come up here to the top. And then it needs to come back down to pi. We didn't draw it, but if you did, there would have been another point right there at 3/4 pi. So it would have gone up and then come down. And then down here in this bottom half, it's going to go down and then back up. I'll draw that a little better. Not much better, a little better. Okay, so that's what we get for our graph. Okay, so right here at pi over 2, there's a maximum. Let's summarize some information. So on 0 to 2 pi, that's what we plotted. Right, the maximum value is 1 right here, right? That's where the maximum is. There's a maximum at x equals pi over 2. M. There's a minimum at x equals down here at 3 pi over 2. It goes through 0, crosses y equals 0 at a couple of places, right? There's one at 0, we've got one right here, and one right here. 3 places where it goes through 0. X equals 0, x equals pi, x equals 2 pi. Right? And then that's just kind of a little summary of what that graph does there. Okay. Now, that was one revolution around the circle that we graphed, right? We took all the values from starting here and we went around the circle one time and we came back. But what if we continued? What if we continued this? What if we kept going past 2 pi? Well, what'll happen past 2 pi if you've gone one full revolution? That is not what I wanted. If you go one full revolution around the circle, you're back to where you start. So you're going to get the same values again. Why does it do that? So you get the same values the next time around the circle. And then you get the same values the next time around the circle. Right? So what happens is every single time around the circle, you just keep going through the same points. And so this graph here that you have between 0 to 2 pi is just going to repeat itself forever. So here's a graph, an example. So let's see here, maybe a little bit further. Right, so if I make a big graph for x and for y here, and I just go like this, let's say pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 6 pi, wait no, that's 3 pi. Why'd I put a dot? That doesn't make sense. 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, 6 pi, 13 pi over 2, 7 pi. Okay, that's plenty, right? And let's say that we go between 1 and -1, because those are the biggest and the smallest values that we saw. So what does this graph look like if we're graphing a sine? Well, we already know a lot of the points, right? It's 0, 0. It's 0, 0. Well, yeah, 0, 0 as 0 is what I was going to say. But 0, 0. And then you have pi over 2, comma 1, so it's up here. Pi, comma 0, so it's down here. 3 pi over 2, negative 1, so it's down here. 2 pi, so it's right here. So if I connect those dots, I'm going to have the graph that I already drew. Right? Now, if I keep going, this is back at the start of the unit circle, right? Because 0 and 2 pi are the same place. So So if I keep going, I'm going to repeat these same values. So it's going to go back up to 1, back down to 0, back down to -1, back up to 0. Then you're at 4 pi. Well, 4 pi is also here. Oops. 4 pi is also here. 4 pi. 6 pi, right? All of those are in the same place because 2 pi is all the way around the circle one time. So we keep going. That was my calculator falling. And does the same thing again. Not any better at drawing it, unfortunately. There you go. So there's a bigger graph. Okay. Now what's it do on the other side? Well, the same thing actually. So if instead of continuing it from 0 on to the right, you continued it from 0 on to the left, it'll do the exact same thing. So the point down here will be down here, and then it'll come back up, and that's about as far as my graph goes. And also, terrible things happen on my graph is what I'm looking at. I did not draw it symmetrical at all. Oh, that makes me very sad. We're 15 minutes in, I'm not resetting. What I am going to do is I am going to have to erase a bunch of this graph and draw it real quick. Eraser. Actually, hold on. Undo, undo, undo. Okay, we're going to do this very quick. So what I did was I put a lot of those points not at 1. I drew them in the wrong place. I drew them way too high. So this one must have been the problem. It's because the numbers were in the way. And that made me want to draw it lower. Okay, now let's connect the dots. Okay, close enough. Okay, so there's my graph, okay, and it's now even above and below the y-axis. So that's what y equals sine x looks like, okay? So you're gonna have to answer some questions about this on the homework. And you know, they're not gonna be hard, but you're gonna need to know what the graph looks like. So let's see here. Getting a question from the book. That's weird. Graphs of sine and cosine graphs. I think I'm in the wrong assignment. Let me get back here. Very confused. Okay, well, anyway, it doesn't matter. So there's lots of questions we could ask about this. Here's one type of question. Example. I could say in, let's say, 4 pi to 6 pi, where does y equals sine x have a maximum? Now you can answer it from, well, this graph if you are careful, right? Like, so let's look at this graph here. So 4 pi to 6 pi, where's that? So the 4 pi is right here, and 6 pi is over here. So we're looking in this section of the graph, right? Just that section. Well, where's the maximum? The maximum there is right there, right? At the peak. So you would need to look at the graph and say the maximum is at x equals 9 pi over 2. That's where it is. Now, let's say you're not looking at this graph and you need to answer that question. What you would do is you would get a graph. easiest way to get a graph is going to be to go to Desmos.com, graphing calculator, just click graphing calculator. You get here, let me put it in presentation mode, make it easier to see. Now I'm going to type in y equals sine x. Y equals, how do I get sine? Functions? Sine x. Okay, so there's y equals sine x. One thing you'll notice is that this graph is not, so I can pinch and zoom and all that stuff, but notice that there's no pi's on the graph. That makes it hard to find any values. And so what you want to do is click the little wrench icon above the plus here, right? Where I just clicked here, upper right. And you'll notice that there's a check mark next to x-axis, and there's some numbers there, right? So the numbers are going to be based on, what kind of, like how far I've zoomed in. Like it says like negative 4.3 for the x. And that's because if you look at the x value over here on the left, it was just past negative 4. So negative 4.5 now. But what you can do is if you add a pi here, or here where the step is, if you put in pi for the step, then it'll start labeling things in pi's. And that's a lot more helpful for you. So now if you were answering the question, in between 4 pi and 6 pi, where's the maximum, you can just scroll over to the section that's 4 pi to 6 pi, and you don't see all the numbers, but if you zoom in, you will. Right? So there's a maximum right there at 9 pi over 2. And you could find a minimum, 11 pi over 2. Right? Where does it go through 0 in there? Right at 5 pi. So those types of questions are really easy when you can make a graph on Desmos. So like you could answer the same questions over here on the negative side, right? You just scroll over and there you go. So you want to take advantage of tools like this to help you answer those types of questions. Okay. Now, while you're looking at this though, I want to point something out. So if I go to pi over 2, what's the y value at pi over 2? Right? It's like 1, right? It's up there. It doesn't say pi over 2 because that's a decimal number and it's hard to press it in the exact right place. But pi over 2 comma 1, right? Well, look at the part, what happens at negative pi over 2? At negative pi over 2, you're at negative 1, right? And that's because if you look at this section of the graph here, it's positive. And if you look at this section of the graph here, it's negative. But they're the same shape though, right? Like this shape over here, this like peak, is the same shape as this valley. The only difference is, it's negative. And so that actually will give you a rule that you're going to need to know. So a rule that you're going to need to know is this. So fact, sine x is an odd function that means sine negative x equals I wrote that wrong already. Negative sine x. Okay, and this fact here, that's what makes it an odd function. That's the definition of odd. Okay, so here's fact. Sine x is odd. That means sine negative x is negative sine x. Why do you need to know that? Because they're going to ask you questions like this. Example. Given sine x equals negative 8 over 9, what is sine negative x? Okay, and the way you would answer it is you would say, well, we know sine negative x equals, you're just going to write down this. Sine negative x is negative sine x, right? But then what is sine x? They told you right here that sine x is negative 8 over 9. So it's negative 8 over 9, which is positive 8 over 9. And then that would be your answer. Okay? Because what you're saying is this. So I'll draw a little picture just to illustrate the idea. So if sine x is negative 8 over 9, right? So that means you've got a piece of the graph here, and then like maybe this is where x is, so that when you come down here, it's at negative 8 over 9. Well, what does that look on the other side? Well, if you graph it, right, it's kind of the mirror image. So if you go this far on the x-axis, you would have to go that far on the x-axis in the other direction to get to negative x. And when you did, you would come up here and it would be at positive 8 over 9. Right? Due to the mirror image. And I know that I didn't draw that very well, so it may not be as convincing as it should be, but hopefully the real graph makes sense to you. So you need to know that fact. That's something that you have to answer on this homework assignment. What else do we have to do in here? A bunch of those. Surprising bunch of those. Okay. I think that's good so far. Let's look at cosine now a little bit, and then we'll come back to the sine function. So what should you be able to do? You should have an idea of what the sine function looks like. One thing to keep in mind is that 0, 0, right? It goes through 0, 0. And then from there heads up. Keeping that straight in your head is helpful for graphing these. All right, let's do cosine graph now. Cosine graph. Okay, so we're going to need a set of x and y values again, just like we did before. X, and then y is cosine x. Let's just pick 0, pi over 2, pi, 3 pi over 2, 2 pi again, just like we did for the sine. Now we need to go back to our unit circle, which I'll scroll up for. And actually let me erase some stuff here off of it. And maybe I can steal it. I think too much stuff is going to come with it. Yeah, the line does. Copy. Paste. Can I resize or no? Is that impossible? That might be impossible. Yeah, probably. I'm just going to leave it like that. So let's look at that. So for the cosine, remember you're going to be looking at x values. So what you're going to be looking at are, when you do sine 0, you're going to be looking at the x value there. So the x value is going to be 1. And then when you go up to pi over 2, we're skipping over pi over 4 because we are lazy. So we're going to jump to pi over 2. And the x value there is 0. Just highlighted it in green. Then we jump to pi. So the x value is going to be minus 1. Keep going. We get to 0. 0. And if we go all the way around the circle, we get back to that 1. And so we get these values. Okay? So now let's graph that between 0 and 2 pi. Kind of want this gone now. It's going to make it go away. delete, delete, delete. Cut. It's gone. Okay, cool. So what are we doing? So we're going to try to graph this, okay, between 0 and 2 pi. So put this line in. Can't even draw a straight line. Okay, we're going to plot this between 0 and 2 pi. So let's put a pi over 2 there. 0 is right there. How many did I do? 1, 2, 3, 4. 1, 2, 3, 4. That's pi. 1, 2, 3, 4. That's 3 pi over 2. 1, 2, 3, 4. That is 2 pi. All right. Now, where is 1 and negative 1? Let's put 1 up here. Well, I think we did something slightly different last time. Let's go 4 boxes. 1, 2, 3, 4. 1. 1, 2, 3, 4. Minus 1. All right. Now let's graph this. So this is going to be a graph of the cosine function. So we've got 0, 1 for our first point. So that is up here. Right? That's not what the sine function did. It's a different shape. Well, same shape, but starts in a different place. So we got 0, 1. Then you've got pi over 2 comma 0. Then you've got pi negative 1. Three pi over 2 comma 0. And then 2 pi comma 1. So there's your graph. So when you graph this, what it looks like is this. If I scribble over it enough, it'll look neat, right? Okay, good enough. So that's what the cosine graph looks like there. Now, just like the sine graph, this graph repeats because you've gone all the way around the circle once, and if you keep going, then the pattern will repeat itself. I'm not going to plot as much of it as I did for the sine. I'm just going to graph a little bit of it here. So let's go pi. Can we do that? No. Let's do. Okay. Pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi. And so the pattern's just going to repeat itself. So we're starting at, let's put 1 up here and negative 1 down here. So we're starting at 0, 1, which is up here. Then pi over 2, 0. Then pi negative 1. 3 pi over 2, 0. 2 pi comma 1. And kind of comes out flat and then goes down like that. And then the pattern repeats. So we're up at 1. Then it goes down to 0. Down to negative 1. Back to 0. Up to 1. So like that. And then back to 0, down to negative 1. Like that. And out to the left, it does the same thing. So if I come out here to negative pi over 2, we're at 0. Right? So the pattern repeats. And then it keeps going. Okay, so you would be able to answer questions about the cosine the same way as you would about the sine now. So if I say, example, in, let's say, negative 5 pi to, 5 pi? No, I want an even number, sorry. Negative 6 pi to negative 4 pi, what x value is the minimum at? The minimum of y equals sine x. Sorry, cosine. We're doing cosine now. Cosine x at question mark. Okay? And again, I'm going to advise you should use a site like Desmos to help you. So negative 6 pi to negative 4 pi. So we go to Desmos, change this to a cosine. That's all. Did not do that. Functions, cosine x. If you're on a computer, you don't have this little keyboard here. You just type in cosine x. All right, so there's a cosine. Looks like we expect. We're between negative 6 pi and negative 4 pi because that's what I said. So you come over here, negative 6 pi to negative 4 pi. So it looks like I have that now. And where is the minimum at? So just looking at this, I see that there is a minimum right down here, right? And the x value is negative 5 pi. So negative 5 pi. So I come back here and I say x equals negative 5 pi. That's where. All right, so you just graph it and get the value that way. Okay. Now, another thing you can do is we can solve the equivalent of this question, right? So how I said sine x is odd, and that means sine negative x is negative sine x. Well, there's an equivalent for cosine. The equivalent for cosine is this. So cosine x is what we call an even function. That means cosine negative x is actually just cosine positive x. Now the reason that's the case is because just look at the graphs here. So look at sine. Remember what sine did right here? What happens over here for the sine is actually, if you go to the other side of 0, right? 0 is right here, is negative, right? So on the right it's positive and on the left it's negative. Whereas if you look at what a cosine does, which is here, if the right side of 0 is positive, I don't know why I turned that into a line. If the right side is positive, the left side is also positive, right? They're both above 0 at the same time. And so that is why it's even. Now, what can you do? Of course, you can answer simple questions involving that. So like an example where you have to know this is they say, given cosine x equals 5/7, what is cosine negative x? And again, all you're going to do is just apply this right here. So you just say, well, cosine negative x is just cosine x, which is what they say it was, 5/7. So the difference between the sine problem and the cosine problem is that this is the same sign as the original. Whereas with the sine function, right, they gave me negative 8/9 and the answer was positive 8/9. So it was the opposite sign. Whereas with cosine, if they give you a positive, the answer would be positive because it's an even function. Okay, let's see what else is in here. Bunches of those even and odd things too, by the way. Don't know why they like them so much. They're pretty easy. I think there's some more complicated graphing problems. Okay, yeah, there we go. Now we have the more complicated ones. So once you have an idea of what the basic graphs look like, you need to remember what we call translations, like scales and translations of functions. or transformations of graphs. I'll say that's what you should know. Transformations of graphs. Okay, and you've learned this at some point in your life. If not, you're going to learn it now. So let's see here. This is for a sine or a cosine, but I'm only going to write it one way. For a sine or cosine. Same thing. So if you have an original graph, right? The original graph is actually, I don't want to say it there. I have to say something. So suppose, right? So for purposes of writing this down, so suppose the original graph is y equals sine x, but you could do this for a cosine as well. It's all the same stuff. Okay. Y equals sine x minus a. I'll put an a there. That moves the graph to the left. This a, let's see, is shifted. Did I say left? I should not have. It's shifted right. Is shifted to the right by a units. Okay. Now, if it's a plus, like x plus a, that is shifted to the left by a units. So let's look at it. Let's go back to Desmos where we can see this. It's true for sine or cosine, so I'm just going to use what we have, which is a cosine. So let me go up here, and I'm actually going to put in minus, and I need an a or something. Let's go there and put a. And so when I type in x minus a, it says add slider a. I can click on that, on the a, and it should add a little slider for a. And now what you see is that I have a slider where I can see it working. So you see when I increase the a, it moves the graph to the right. And if a goes negative, which think about that, if I have like right here, if I have a negative, I can't write on this, but if I have a negative 0.6 for a, that's actually x minus 0.6. So that's x plus 0.6. And we saw here that a plus moves it to the left. And so the way I wrote it, if I put a negative for a, that is a plus. So that's why negative values for a here move it to the left. Okay, how do I get back to the slider? Right. So that just slides it left and right. That's what adding a number right there does. Okay, well, what else can we do? We can add a constant outside of the sign. So notice that the a was being added to the x value, and now I'm adding the b outside. So if I add a b there, that is moved up by b units. And you'll never guess what putting a negative there does. Never in a million years would you have guessed that that moves it down. By b units. Okay, so go back to my Desmos graph. I'm going to get rid of this. Delete, delete, delete. Get rid of that. So if I go, what do I want? A plus? How do I get a plus? Plus and lowercase b, because that's what's easy. Add slider. Let's add a slider. Slider. Right? So that moves it up and down. So when it's a 0, we're not doing anything, right? That's the original graph. Oh, well, it was before I changed it. But if you move it up, it moves the whole graph up. Okay, so that's what adding a b there does. All right, two more things. We can add y equals sine, I guess I want to call it a different letter. I'll say cx. What's that do? That actually squeezes, which we would call that compression. So I'll say compresses the graph horizontally by a factor of c. Now, you might not know what that looks like, but that's why we're going to graph it. So if I come back up here, let's get rid of that. Come here, let's put a c there, c. Okay, so let's see what happens. So when c goes up, the graph is going to get skinnier. See? What it does. So the bigger the c, the skinnier the graph gets, and we call that compression. So like when I say, so look at what happens. If I have a 1, that's the original graph. And so look at where this value is right here. That's at pi, right? So if I change this c to a 2, where does that happen now? Now it's at pi over 2 because we squeezed it in by a factor of 2. It's twice as skinny now. If I go up to a 3, now that's at pi over 3 because it's 3 times as skinny. If I go up to a 4, now this first minimum here must be at pi over 4, which it is. Well, I moved off 4, but if I get it in the right place, there's where it is. So 4 times as skinny, right? So the bigger you change that, or just get skinnier and skinnier. And same thing if you go to close to 0. Closer to 0 makes it very wide. Yeah. So if you go less than 1, what happens is if you compress, it, which is squeezing it in, by a factor of 0.5, then you're not actually squeezing it in. You're compressing by a factor 0.5 is actually stretching by a factor of 2. So above 1 values make it skinnier, and in between 0 and 1 you make it wider. All right, back here. Nope, that's where we just came from. Notability. One more. Y equals, let's say, d sine, no, not sine cx, just sine x. So if you add a constant out front, that just stretches it vertically, makes it taller. Stretches it vertically by a factor of d. Let's go look at that. So let's take away this c, go in front, let's put a d, add slider. All right, let's see what it does. So if this gets bigger, the graph should get taller. Nothing else changes though. It's just taller, shorter, taller, shorter, taller, shorter, taller, shorter. Right? Easy enough. So there you go. What are we going to do with it? Well, in this section, we don't do too much, but we're going to have questions like this. So like, example. They say, oops, I don't need a y. they just say like, which graph is f of x equals negative 1/2 cosine 4x. And so what you would need to do is recognize what the numbers do. And also, we didn't talk about a negative out front, but I'll show you that right now, actually, before we move on. So let's go back here. So what happens is, like, this is when you have a 1, that's the original graph. Now, as you go close to 0, the graph gets shorter and shorter. When you go negative, then the graph's upside down, right? So cosine normally has a peak at 0, right? That's where the highest value is. It's at 0. But if you go to a negative 1, I did negative 2, but if you go to a negative value, then instead of being at the top of a peak, it's at the bottom, right? So positive value, it's like that. Negative value, it's like that, upside down. So back here, this negative 1/2 does two things. So you identify what they do. So it's negative, which means it's upside down, right? That's what I just looked at, compared to the original cosine graph. The fact that it's a 1/2, that means it's instead of stretched vertically, well, stretched vertically by a factor of 1/2 means it's actually half as tall. 1/2 as tall. So it's upside down. It's upside down and half as tall. Then what's the 4 do? Well, the 4 is where we have compression, right? Compresses the graph horizontally by a factor of c. So that's compresses horizontally by factor of 4. Now, you could just have gone to Desmos and graphed this and you would know what it looks like right away, right? So you don't even have to understand the numbers if you have a computer. But here's how I'll do this by hand, just to give you an idea. So the normal graph of a cosine starts at 1. Okay, and let's see. Let's say this is pi over 2. This is pi. Then it goes down to 0. And then it goes to negative 1. Like that. And, it keeps going, so like that. So this is the normal y equals cosine x graph. All right, so here's what you should think. Let's look at these things. So first of all, it's compressed horizontally by a factor of 4. So like this wouldn't be, the equivalent of this point wouldn't be at pi now. It would be at pi over 4, which is way over here. So it would be like this. Right, so like that. No, actually that's completely wrong. It would be, well, yeah, I mean, it would be there, but we have more stuff. So it's negative. I just erased that. So it's negative, so it's upside down. So instead of looking like it looks, it's like this, right? That's the upside down part. But then it's half as tall. So if it's half as tall, then it would actually be like this. Right? Half as tall. If I drew that half, I don't know if I did. But then it's compressed horizontally by a factor of 4. So like this point would be moved in by a factor of 4. So that would actually be over here. So you should expect like a graph that's skinny and half as tall. And I realize that it's really hard to see what I just did here. But skinny, half as tall, upside down. So let's look at it. put the original graph on here. So that's the original. Y equals functions cosine x. Okay, so what do we got? So out front, if I make it negative, it's upside down. If I put a half there, I'm just going to type it 0.5 because it's easier to type. I can't type it. Okay, I can. So now it's half as tall. Okay, and then if I put a 4 here, it'll make it 4 times as skinny. There it is. Right? So upside down, 4 times as skinny, half as tall. And that's it. So there you go. That's the graph. So if you were looking at 4 to choose from, it would be easy to pick the right answer. So again, use the resources available to you. Use a computer for these. All right. There, I'm not going to graph it there. Okay. Is there anything else we need before we move on? Because this is a long lecture already, because drawing takes me a long time. Honestly, I think that's it. So that's it for this lecture. We're going to graph more of them in the next lecture. More graphs. All right, we're done.